So, if you drive past your local landfill today, I really want you to look closely at that massive mountain of trash. Because, well, 40% of everything sitting in that dump, nearly half of it, used to be a building.
Yeah, or at least a big part of a building process.
Right. I mean, we're talking about steel, glass, concrete, timber, all this stuff that was mined, manufactured, and transported at an incredible expense, basically just to be buried in the dirt.
It is pretty wild when you actually stop and think about it.
It really is. And well, welcome to the deep dive. Today we're unpacking a stack of sources, but we're primarily looking at this highly detailed market intelligence report. It's called The Economics of Circular Construction and Material Reuse.
Which is a very dense title for a really fascinating topic.
Seriously. But for you listening, our mission today is to completely reframe how you think about sustainable building. Because, usually when we hear sustainable building, we think of it as like an environmental plea.
Right, or a PR move so a company can put a green plaque on their wall.
Exactly. But we aren't looking at it that way today. We are framing this as a pure, hard-hitting, ruthless economics problem.
Because that is exactly what it is. The transition from this traditional take, make, dispose mindset to a circular one, it's fundamentally about restructuring project costs.
It's about the money.
100%. It unlocks entirely new revenue streams. Legacy companies right now are bleeding value at just an astonishing rate, largely because they're ignoring this massive inefficiency in their supply chains.
So it's not just about hugging trees.
No. I mean, mastering material reuse isn't just about saving the planet, though, that obviously happens as a byproduct, but it's really about gaining a structural cost advantage that your competitors simply cannot match.
Okay, so let's start with the sheer scale of the leakage here, because the data in this report is it's staggering.
The 600 million tons figure.
Yes. The construction industry currently generates 600 million tons of waste annually. And that's just in the United States alone.
Which is almost hard to even conceptualize.
It is. Think about the unit economics of that for a second. Imagine a traditional manufacturing plant, right? Like a major car manufacturer.
Sure.
They deliberately buy millions of dollars of premium, high-grade steel, glass, wiring. They run it all down the assembly line, and then right before the cars are finished, they take 40% of those brand new engine blocks and chassis, and they just toss them into an incinerator.
And then they pay a completely separate company to haul away the ashes.
Exactly. I mean, the shareholders would revolt, the executives would be fired by lunch.
Oh, absolutely. The company would go bankrupt overnight.
Right. Yet the construction sector is somehow incredibly comfortable with this wildly inefficient linear model. Why is that?
Well, the wild thing is the industry didn't adopt this wastefulness by accident. It was actually baked into project accounting over a century ago.
Oh, really? So it was intentional.
In a way, yeah. For decades, the linear mindset was just the path of least resistance because land for dumps was virtually limitless.
Ah, right. It was cheap to just throw things in a hole.
Exactly. Tipping fees, the price you actually pay per ton to dump waste at a landfill, they were incredibly cheap. And at the exact same time, the global supply chains for brand new virgin materials were highly optimized.
And probably heavily subsidized by cheap fossil fuels for transport, right?
Spot on. So project estimators, they simply wrote in a line item for dumpster rentals and disposal fees, and nobody even blinked an eye.
It was just part of doing business.
Right. Mathematically, it was literally cheaper and faster to just throw a perfectly good steel beam into a landfill than to pay a specialized labor crew to, carefully dismantle it, sort it, and store it.
So the labor was the expensive part, and the trash itself was essentially free to get rid of.
Precisely.
But, okay, tipping fees are now skyrocketing because landfills are actually reaching capacity. And, virgin materials are facing wild price volatility with all the global supply chain chaos lately.
Right, so that old math, it just doesn't work anymore.
That makes sense. That line item for waste disposal is suddenly, eating into the profit margins of every single project.
It is becoming a massive financial liability.
Which really makes you wonder, if throwing things away is suddenly costing an exorbitant amount of money, what happens to the contractors who intercept that waste before it ever hits the scale?
Well, that is the million-dollar question.
Right. Are they just saving on disposal fees, or is there a secondary market here?
Oh, they are tapping into a massive secondary market. Intercepting that waste transforms what used to be a sunk cost into a legitimate revenue-generating asset class.
Okay, tell me more about that because it flips the whole model on its head.
It does. The hard data in this market intelligence report shows we aren't just talking about using reclaimed materials as like cheap, low-grade substitutes.
So it's not just buying cheap scrap.
No, not at all. Salvaged steel, recycled aggregates, reclaimed bricks. They're currently commanding a 15 to 25% market premium over virgin material.
Wait, okay, let's unpack this because that is a massive psychological leap for me.
I know, it sounds totally counterintuitive.
It really does. Why on earth would a developer pay a 20% premium for a used steel I-beam when they could, just buy a brand new one for less money?
2 words for you. Carbon math.
Carbon math. Okay, explain how that works.
So in major commercial real estate markets today, buyers, developers, huge corporations, they are all bound by incredibly strict embodied carbon targets.
Embodied carbon being the carbon footprint of actually making the building materials.
Exactly. So if a developer builds a commercial office tower in a city that has, say, a carbon tax or really strict emissions penalties, the virgin steel they buy carries massive embodied carbon from the smelting and mining process.
Right, because making steel is super energy intensive.
Very.
Yeah.
But salvage steel, it carries almost zero new embodied carbon. The carbon was already spent 50 years ago when it was first made.
Oh, wow. I see where this is going.
Right. So while that salvage steel might cost the developer an extra $20,000 up front to procure, utilizing it might help them dodge $50,000 in carbon offset taxes.
Or they might get like a much better interest rate on a green construction loan or something.
Exactly. Paying that 20% premium for the material is mathematically the cheapest way for them to hit their overall financial targets.
That is brilliant. So they aren't paying for the steel itself, not really. They are paying for the carbon math attached to the steel.
You got it. That is the premium.
And the sources highlight some pretty incredible real-world examples of how contractors are actually executing this at scale, too.
Yeah. The UK AgNet Challenge is a perfect example of this.
Yes. Let's talk about that. Because instead of just tweaking the old model, they just completely bypassed the traditional supply chain.
What's fascinating here is the logistical shift they managed to achieve. Because traditionally, if you want to build a road or a foundation, you go blast rock at a quarry.
Right.
You load it into these massive diesel trucks, drive it 50 miles to the site, and dump it. Meanwhile, you have another entirely different fleet of trucks hauling the demolished concrete from the old building away to a landfill.
It's just trucks crossing each other on the highway, burning fuel.
Literally. But the UK AgNet model intercepts this entirely. They bring these massive, mobile mechanical crushers directly to the demolition site.
Which is just so smart.
They take the old building, they pulverize the concrete right on the spot, and then they use that pulverized material as the foundational aggregate for the new project.
So they are literally grinding up the problem and then standing on it.
Exactly. Zero quarrying, zero transport costs, zero landfill fees.
And the report dives into specific general contractor case studies showing the financial impact of this, right? I mean, these GCs aren't just shaving a tiny fraction of a percent off their overhead.
No, they're achieving 25 to 35% overall waste cost savings on major projects just by integrating material reuse.
25 to 35%. That's huge. They are literally pulling profit out of the dumpster.
When you own the material and the processing network, your demolition phase goes from being this annoying liability to literally the procurement phase for your next project.
It turns the entire life cycle of a building into this closed loop of profit.
Precisely.
But hold on. I'm doing the math here in my head.
Uh-oh, here we go.
No, really. If I'm a contractor and I can slash my disposal costs by 30% on the demolition side, and then I turn around and charge a 20% premium on those salvaged materials for the new build, this is basically a money printer.
It definitely looks like one on paper.
So there have to be a catch. I mean, why isn't every single general contractor on Earth pivoting to this model today?
Because the friction is incredibly high.
Oh, okay, for sure.
The economic incentives are totally clear, yes. But the operational realities act as a massive bottleneck right now. The sources outline a few major structural hurdles.
What are we talking about? Like finding the stuff?
That's one. You have highly fragmented supply chains, Then there's a severe lack of transparency, immense design complexity, and really steep upfront coordination costs.
Okay, let me play devil's advocate here on behalf of the everyday contractor listening to this.
Go for it.
So I'm a contractor. I'm dealing with brutal project deadlines. I've got weather delays, labor shortages, and razor-thin margins.
A standard Tuesday in construction.
Right. So the idea of relying on a, quote, fragmented supply chain to find a perfectly sized, salvaged steel beam for a critical structural load, that sounds like an absolute logistical nightmare.
I don't blame you for thinking that.
Because if I order new steel, it shows up on Tuesday with a beautifully stamped certification from the mill saying exactly what it can hold. How do you guarantee safety and quality when you're essentially shopping for used building parts?
And that right there is the crux of the issue. If we connect this to the bigger picture, the core bottleneck isn't a lack of desire to save money. Everyone wants to save money.
Right.
It's a lack of standardized testing. When you pull a steel beam out of a 50-year-old demolished warehouse, you have no idea what its thermal history is.
Thermal history, like if it got too hot?
Exactly. Was there a fire in the 1980s that weakened the structural integrity? You don't know. Was the beam consistently overstressed by heavy machinery for 3 decades? You don't know that either. And it certainly doesn't come with a modern mill certificate.
Man, it's like being asked to build a bridge with a giant bucket of random Legos, but half the Legos might have invisible microfractures. And if the bridge falls down, the architect goes to jail.
That captures the liability perfectly. Engineers are, by definition, highly risk-averse people.
As they should be. We want buildings to stand up.
Exactly. If they cannot mathematically prove the material is safe, they simply will not sign off on the structural drawings.
So how do you actually solve this?
Well, you have to test it. But you can't just look at a piece of steel and say it's fine.
Yeah.
You have to bring in specialized ultrasound equipment to scan the internal structure for those microfractures you mentioned.
Ultrasound?
Yeah.
Like they use at a hospital?
It's a very similar concept, yeah. And for reclaimed concrete, you have to take core samples, transport them to a lab, and physically crush them in a machine to determine their exact PSI rating.
Wow. Which I'm guessing takes a tremendous amount of time?
It does, and it completely flips the traditional workflow.
Right, because usually an architect designs a beautiful building first, and then the procurement team just goes out and orders the parts to match the drawing.
But now they have to see what salvaged parts actually pass the ultrasound tests first. And then the architect has to reverse engineer the design to fit the parts they actually have.
Oh, that sounds like a headache.
It drives up upfront coordination costs exponentially. It requires the architect, the structural engineer, the general contractor, and the demolition team to all be sitting in a room collaborating months before a traditional project would even break ground.
Okay, here's where it gets really interesting though. Contractors might be looking at all those testing hurdles, the ultrasound bills, the design headaches, and thinking, you know what, I'll just wait. I'll wait a decade until the supply chain figures this out and testing gets cheaper.
That would be a huge mistake.
Right, because the market intelligence suggests they literally do not have that luxury. The market demand is not waiting around for the logistics to get easy.
Not at all. The pressure is mounting rapidly from the top down. Right now, 60% of all institutional construction RFPS requests for proposals are actively specifying material reuse and circular design as a non-negotiable requirement.
Wait, 60%, more than half?
More than half. Just to even bid on the project, if you are a commercial contractor and you don't have the workflows in place to test and source reclaimed materials, you are getting locked out of more than half of the institutional bids before the process even starts.
Wow. And it's crucial for everyone listening to understand the regulatory mechanisms driving this too, because it's not just local city councils pushing nice green initiatives.
No, we are seeing the ripple effects of heavy global policies. The sources point specifically to the EU's EPR regulations.
EPR, that's extended producer responsibility, right?
Yes, exactly. And EPR completely changes the legal framework of manufacturing.
How so?
Under an EPR regulation, if you manufacture, say, a commercial glass window, you don't just sell it and walk away anymore. You are legally responsible for the carbon footprint and the physical disposal of that window until it is destroyed or recycled, maybe 50 years later.
So the liability literally stays with the producer.
For its entire life cycle, it forces the whole supply chain to design products that can be easily dismantled and reused, because that original manufacturer definitely doesn't want to pay a massive disposal penalty down the line.
That makes total sense. And while those are European laws, the report notes they are already pushing U.S. states toward implementing their own localized circular mandates.
The dominoes are already falling here in the States.
Yeah. On top of that, ESG mandates, environmental, social, and governance, are becoming the absolute baseline standard for large U.S. corporations.
Right. They have strict shareholder requirements to lower their carbon footprints. And honestly, the fastest, most measurable way to do that is through their real estate and construction portfolios.
Because buildings use so much carbon. But there was another detail in the report that blew my mind. There is a major shift happening in government contracting as well.
Yes. The SBA bonus.
Yes. The U.S. Small Business Administration now offers a scoring bonus specifically for contractors who utilize circular construction methods.
Which is huge. When you are bidding on lucrative government contracts, having this capability literally gives you extra points on your application. It alters the fundamental math of who wins the contract.
Which proves that circular construction has entirely shed its old reputation as just, ESG virtue signaling.
Yeah.
It is a hard, measurable, competitive profit lever.
Absolutely.
Because if you can navigate the testing and the supply chain, you get the government bonus, you win the RFP, you save 30% on disposal, and you charge a 20% premium on the material.
Yeah. It is rapidly transitioning from a specialized niche skill to a core competency that's required just for baseline survival in the commercial space.
So what does this all mean for the listener? If you are listening to this and you see the RFPs demanding circularity, you see the regulations enforcing it, and you see the massive financial incentives waiting for those who figure it out, where does this leave the timeline for the construction industry?
The window of opportunity is closing fast.
How fast are we talking?
Well, the primary takeaway from the market intelligence report is that the industry is basically on a ticking clock. The contractors who dive into the friction right now, the ones who master the complex testing workflows and build those specialized supply chains by the end of 2026, they are going to possess insurmountable structural cost advantages by 2028.
Because they'll have the supplier networks totally locked down.
Right. Their engineers will already be perfectly comfortable reading ultrasound reports on reclaimed steel, and they will be reaping those material premiums while simultaneously slashing their disposal costs.
While their competitors will, still be paying premium prices for virgin materials and absorbing those skyrocketing landfill fees.
Precisely. Those who stick stubbornly to the linear take, make, dispose model won't just be less profitable. They will mathematically be priced out of the market.
They literally won't be able to afford to win a bid.
Their baseline operational costs will simply be too high to ever win a competitive bid against a circular contractor.
This raises an important question, though, about the very nature of legacy industries. Because, this isn't just about figuring out how to test old steel, right? It's about massive behavioral change.
It's a complete culture shock.
Yeah. Construction is notoriously heavily siloed. The demolition contractor rarely ever talks to the architect. The architect rarely talks to the procurement officer.
They stay in their lanes.
But circular construction forces all of these distinct, often adversarial groups to collaborate deeply from day one. So how quickly can a legacy industry truly reinvent its core day-to-day culture when its very survival is on the line?
That is going to be the ultimate stress test for the next few years. The companies that survive won't necessarily be the ones with the biggest budgets or the best equipment. They will be the ones with the most corporate agility.
They have to learn to play nice.
They have to break down decades of siloed thinking and rewrite their entire approach to project management.
It really is adapt or die, but played out with steel beams and concrete.
Pretty much.
Well, whether you work in commercial real estate, supply chain logistics, project management, or if you are simply fascinated by macroeconomic shifts, this is a masterclass in market adaptation. Watching an enormous, traditional industry figure out how to turn its literal trash into its most premium treasure proves that the most sustainable solution ultimately wins when it fundamentally changes the unit economics of the business.
Well said.
And to leave you with a final thought, to mull over something that pushes everything we've talked about today just one step further, we spent this entire deep dive talking about tearing down old buildings and struggling to test and reuse the old parts. Right. But what if we stopped thinking of buildings as permanent end products altogether? What if the buildings of tomorrow are designed specifically to be material banks?
Material banks. I love that concept.
Constructed today with the explicit planned intention of being easily unbolted, dismantled, and sold for parts at a premium in 50 years. Imagine a city that never throws anything away, but just endlessly reshuffles its own geometry.
That really is the true end game of circularity.
It really is. Well, thanks for joining us on this deep dive. We'll catch you next time.